If you're looking for an alternate method for graphing and your teacher doesn't require you to use graph shifting, another possibility is you can graph these using a chart. Now, the problem is that if you're always going to use the points -1, 0, and 1, when you're not just dealing with the parent function, sometimes you'll end up with some very small numbers that won't really give you a good picture of your graph. So I'm going to give you 3 points that when you plug them in will always give you a good picture of the graph so that you're able to find the locator point and work from there. So if you remember, we said in the previous videos on graph shifting that with the parent function, we always liked -1, 0, and 1. The problem is that if I'm plugging these points into the actual function that I have up here, I'm not going to get those kind of desired 3 numbers that I work with that are easy to calculate and easy to find and will give us, a nice picture. So what I'm going to do is actually change these points by first figuring out what makes this top 0. So what makes this exponent up here 0? So to find this, again, we could solve x minus 2 equals 0. So what makes that exponent 0? And if I add 2 to both sides, I'm getting that x equals 2. That is your locator point. So what I'm going to do here is instead of using 0 for the locator point, it's shifted over 2. I'm going to put 2 as the locator point. And there's 2 ways you can think about this. You can think about this as we need 1 number above 2 and 1 number below 2. Or you can think about it as, if we had these original 3 points that we said are pretty good, we can just add 2 to each of those numbers and we'll come up with 1, 2, and 3. Now, 1, 2, and 3 should give us a pretty good picture of what's going on the graph. So this is going to be my x column, this is going to be my y column, and then this column will be the 2 to the x minus 2 plus 1 column. I'm basically going to plug in the x value here. This is like my work column. So if I start this off, I'm going to plug this in as 2 to the 1 minus 2 plus 1. And that 1 minus 2 I need to do first. So that's my exponent. This will be 2 to the -1 plus 1. And 2 to the -1, that's just 1/2. So a half plus 1, that's going to give me a y of 1.5 or 1.5. That'll take care of the first y value there. Next one we'll look at, we'll do 2 if we plug this in. This should make the exponent 0. That's what I was hoping for this middle locator point here. So this would be 2 to the 2 minus 2 plus 1. And we know that 2 minus 2 is 0, and anything to the 0 power is just 1. So this is really just 1 plus 1, which is 2. So I've got 1.5 and 2 for my first 2 y values. The last one here, again, if I subtract 2 to the 3 minus 2 plus 1 equals, so 3 minus 2 is 1, so that gives me 2 to the 1 power, and you can see now these numbers, -1, 0, and 1, actually come out in the exponent after I've picked these new points. And 2 to the 1 plus 1, 2 to the 1 is 2, plus 1 should give me 3. And now I've got the 3 points that I could use to graph. So I didn't need to shift anything around or worry really about a parent function. I just had to pick 3 new points instead of -1, 0, and 1. So let's graph the first one. We've got the point 1, 1.5, so that would be at 1, 1.5 right here. And next up we've got 2, 2, that would be right here. And then we've got the point 3, 3, which would be right here. And we can start to see this, this exponential function take shape. Another thing to remember is it's good to graph the asymptote to get a picture of that. The asymptote is always going to be at that plus number when we're in this form. So our horizontal asymptote, I'll abbreviate here for this video, I'm assuming you've seen some of the other ones. The horizontal asymptote is at y equals 1. Remember that that is the equation of a line, so we need that y equals there, not just 1. And now that we've got this, we're going to go ahead and finish the graph. So it should look something like this here. Okay, so that should be decreasing continuously to the left, approaching towards 1, and then to the right we'll be going up towards infinity as we go out further and further with x. Okay, so again, alternate method for these. I'm going to use this same alternate method on the next one. If you want to take a second and try to find the locator point for this and pick the 3x values that should make this picture easy, I'll let you do that now. And if you didn't pause the video to find the locator point, we want to know what makes this 0 in the exponent. And if I subtract this over, I'll get x equals -1. So that means my middle point here is going to be -1, and I just need to go 1 on either side. Now, be careful here. If we're going up 1, it's actually 0, and down 1, it's -2. Not that it really matters too much if you keep yourself organized, but if I kind of keep the same theme there, that's what I should have. So that will give me -2, -1, and 0, and then I'm going to fill in. These are my x values, and I'm looking to find some y values based off of these. So if we go ahead and figure this out here, we've got 0.5 to the x plus 1. I might actually rewrite this in here as, we'll do this as 1/2, because 0.5 is the same as 1/2. I might rewrite this as 1/2 to the x plus 1 plus 2, because those are just the exact same thing. 0.5 and 1/2 are the same. That'll be easier to do in our heads. Now if we plug this in, we'll plug in -2 here first, so 1/2 to the -2 plus 1 plus 2, and that should just be 1/2 to the -1, all in parentheses here, plus 2. And we know that anything to a negative power just flips it upside down. If it's to the -1, that would be just 2. So 1/2 to the -1 is 2. And 2 plus 2 is 4. So this guy should be a 4 over here. If we plug in our next number, we'll plug in -1. Again, this should create a 0 in our exponent. Let's check to make sure. So we got -1 plus 1 plus 2. So -1 plus 1 is going to give me a 1 here. So that this will be to the 0, so anything that's to the 0 gives me that 1. So 1 plus 2 should give me 3. Okay, again, -1 plus 1 is 0. Anything to the 0 power, so this whole thing right here to the 0 power becomes 1, so 1 plus 2 is 3. Now, we're almost there. We plug in our 0, so this would be 1/2 to the 0 plus 1. That's just going to be 1/2 to the 1. It's just 1/2. So anything to the 1 power is itself. So 1/2 to the 1 is 1/2 plus 2. So this y value for our last one should be 2.5. So it would be 2 and 1/2. So we've got 4, 3, and 2.5 for my y value. So now I just need to go ahead and graph these ordered pairs. And let's do that. So we've got the point -2, 4, which will be up here. And this should be decaying, so this should be going down from left to right. We've got the point -1, 3, which would be right here. And we got the point 0, 2, and 1/2, which will be right here. Now, our horizontal asymptote, you should be identifying right here at y equals 2. So our horizontal asymptote here is at y equals 2. So that's going to take this graph and give us an invisible line here that goes across at 2. And then finally, to graph this, we're going to kind of sketch this going downwards this direction from left to right, and it's going to approach that asymptote at 2 as we go towards infinity. Okay, we've got one example left to work on where we're just going to have to use a little bit more with order of operations, and this would be a tough one to do with graph shifting. So, you know, if you did the graph shifting, it's not even a bad idea to check your answer by plugging in these points. So let's start off by finding the locator point here. So you should be pretty good at figuring this out by now. Whatever makes this guy 0 will be the locator point. And I'm just going to do this in my head in this step. I hope you're kind of getting the hang of that. That should be 5. So our locator point here is at 5, which means we need to go to 6, up 1, and down 1 at 4. And if you just plugged in -1, 0, and 1, you're going to get kind of not a very good picture of the graph, or it won't fit depending on you know, what the picture of the graph will look like. So one or the other will happen. I'll leave that to you guys if you want to plug those in to see what would happen on this one if we use -1, 0, and 1. So now we've got our x, we've got our y, and in the middle we're going to have our kind of our work column here. So we'll have -2 times 3 to the x minus 5 plus 3, and this will go in this column in here. So let's start filling in our numbers. So if we take -2 times 3 to the x minus 5, we're going to rewrite this as -2 times 3 to the 4 minus 5 plus 3. I'm going to maybe run out of space here. We'll see. Um, 4 minus 5 is going to be negative 1. So I'm going to sneak some of this down here. So this is negative 2 times 3 to the negative 1 power plus 3. So now what we're going to find from this is that this would just be, so 3 to the negative 1 is negative a third, or excuse me, positive 1/3. So this is just negative 2/3 plus 3. So this is really just if we take 2/3 away from 3, we'll get 2 and 1/3 for our answer here. So 2 and 1/3. I'm going to have to sneak this work, I think, down here for these examples to fit everything in. For our next one, we're going to plug in 5 now. So this would be negative 2. And you should be getting this pattern here that this middle point should work out really nicely, where when we plug this 5 minus 5 in, do the plus 3 here, this is just going to give us all a 1 here. So 5 minus 5 is 0. So this is just negative 2 times 3 to the 0 plus 3. And all that is just negative 2 times 1 plus 3, which is just negative 2 plus 3. And that whole thing is just equal to 1. So that'll just give us a 1 there. Okay, and we'll do the last point here. So we've got negative 2 to the times 3 to the 6 minus 5 plus 3. And again, 6 minus 5 is 1, so we're going to take negative 2 times 3 to the 1 power plus 3. And negative 2 times 3 is just, that again, anything to the 1 stays the same. So this is just negative 2 times 3, which is negative 6, plus 3, which is negative 3 for the answer. Okay, so now we're all set to graph this. The only thing that I would be careful of with these is do not multiply this negative 2 in until you've taken the exponent. Okay, notice in this step down here, I did always do this part first before I multiply by negative 2. Same thing here. I don't want to multiply negative 2, get negative 6, and then take that to the 0. Otherwise, you're not following your order of operations. You have to do your exponent before you multiply that negative 2 in. So be careful with that. So we'll go ahead and graph. So I've got these points right here, and I've got these points right here. And we've got 4 and 2 1/3. So that'd be 4 and 2 1/3 would be a little bit past 2. So it'll be right here. Next up, we've got 5 and 1, which will be out here at 5 and 1. And this should be decaying from, excuse me, not decaying. It should be a flipped upside down exponential graph. And then finally, we've got the point 6, 1, 2, 3, 4, 5, 6, and down 3. And I think I made a mistake here. Let me fix it. Yep, so this was supposed to be at 4, 2 1/3. I'm graphing a little bit goofy here. This should be at 4, 1, 2, 3, 4, and 2 and 1/3, which looks like this. So it is an exponential graph, but it's flipped upside down like this. And you can see that we have our horizontal asymptote at this value right here. So a horizontal asymptote, again, this is the equation of the line, so don't forget your y equals. It's a horizontal line. Horizontal lines always have a y equals there. But our horizontal asymptote is right here at y equals 3, and our graph is approaching that from the lower side as we go towards the left. Out to infinity there. It's going to get closer and closer to 3, but never actually touch that. So again, if you don't like graph shifting and your teacher doesn't mind, this is an alternate method to graph these. The key is that you first have to find what makes your exponent 0, and that's going to be your locator point. That's going to help you find where to start from to get a nice picture of the graph. Okay? Now once you've done that, pick one point on either side of that. Go up one and go down one. And then once you get those 2 points, usually you'll have a nice picture that won't be too squished or too far off your graph.